Fisher's exact test. Background. In the first video of chi-square test, the example was to investigate whether a new vaccine effectively prevents influenza. It was a triple-blinded, randomized controlled trial, where the investigators, clinicians, and analysts remained blinded throughout the study. A total of 400 participants met the inclusion criteria and were randomized into two groups. 100 participants received the placebo and 300 participants received the vaccine. Suppose due to limited budget and time, instead of 400 participants, 40 participants were included and randomized into two groups. 10 participants received the placebo and 30 participants received the vaccine. At the end of study, 5 out of 40 participants contracted influenza. Because the study was blinded before the label was open, it's unknown how many cases of influenza occurred in the placebo group and how many cases of influenza occurred in the vaccine group. Please try out the following two exercises. Number 1, carry out Pearson's chi-square test. You should at least do the following 3 things. First, calculate the expected number, assume the two groups were independent. Calculate the chi-square based on the expected number that you calculated and the following observed numbers. Number 3, calculate the degree of freedom. Second one, evaluate the validity of Pearson's chi-square test. If you don't know or forgot how to do the calculations, please watch the first, second, and third video about chi-square test. Now pause the video, do the above exercise. Let's continue Pearson's chi-square test and validity. We can do row-wise calculations based on the overall probability of influenza. We can calculate the expected numbers for the placebo group and for the vaccine group. 10 times the probability, 0.125, equal to 1.25, is the expected numbers of influenza for the placebo group. 10 minus 1.25 equal to 8.75 is expected number of non-influenza in the placebo group. We can do the same calculation for the vaccine group. Besides row-wise calculations, we can also do column-wise calculations based on the overall probability to be vaccinated. We can calculate the expected numbers for the influenza group and for the non-influenza group. 5 times the probability, 0.75, equal to 3.75, is expected number of being vaccinated in the influenza group. 5 minus 3.75 equal to 1.25 is the expected number of placebo in the influenza group. We can do the same calculations for the non-influenza group. As you may expect, the two calculations will add up the exactly same numbers. Pearson's chi-square test and validity. The first table is the expected numbers. The second table is the observed numbers. Pearson's chi-square compare the observed with the expected numbers. We can calculate also degree of freedom equal to rows minus 1 times columns minus 1 equal to 1. I hope you have calculated the correct numbers. If you need more explanations, you should watch the first and the second video. Based on the chi-square value and the degree of freedom, we can ask a computer to find the p-value roughly equal to 0.4 408. Let's consider the validity of Pearson chi-square test in this case. Based on the third video about validity of Pearson's chi-square test, the sample size in this case is 40, and the smallest expected number is below 5. Therefore, Pearson's chi-square test in this case is not a good approximate. Alternative exact tests should be used. This is the end of this video. See you next one.